Hello, good afternoon, and welcome everyone. My name is Aaron Smith. I'm the CEO of EEBA, and we're really excited to welcome you to the EEBA webinar series. This will be showcased in the EEBA Learning Management System at eeba.org. And in celebration of National Radon Action Month, we're really excited to be presenting best practices to achieve radon-resistant homes. And we've got joining us today Bruce Sneed, who is the Director of Engineering Extension at Kansas State University, as well as Brian Hansen, who is the coordinator for Kansas Radon Program. And definitely an area that's near and dear to our hearts. I know we were talking to Nancy as we got ready for this call. She just had a radon test on her own home and is deploying a mitigation system. So I think, Bruce, all of us on this call are in kind of a radon zone where we definitely want to pay attention to the great material that you're presenting today.
Great. Well, thank you very much. Appreciate the opportunity to share with you, and really encourage everyone to ask questions as much as possible. That's always brings benefit to presentations like this.
Yeah, just go ahead and put your questions in the Q&A section at the bottom of your screen, and we will deal with those when they're best suited in the flow of the presentation. So thanks, everyone.
Sounds great. Well, our goal today is to cover these basic objectives, understand what contributes to the radon concentration we find in homes, and there's radon everywhere. The only way to know the level anywhere is to conduct a test. We can't predict radon levels. So we encourage all of you to do that. If you have not tested your own home, the Surgeon General has recommended that all homes be tested. We want to increase your awareness of current radon-resistant new construction, RRNC codes and standards. Talk about what works and what hasn't worked to achieve low radon results in new construction. We have a great deal of experience with installations across the country and feedback from contractors and mitigators. And then we want to also touch on Indoor AirPlus and the radon requirements there, and for sure answer any questions that you all have about the topic today. So what is RRNC? The basics of RRNC, and I'm going to turn it over to Brian Hansen to share that information with you.
All right. So again, welcome. We're here primarily because of the concern of the additional radiological dosage associated with radon in the indoor environment. That radiological dosage over time increases lifetime risk of developing lung cancer, which is the health concern that we have with radon. And it's worth repeating, even though you may have heard this before, this is not something that we built into the house. It's an artifact of how we build houses. So there's no blame in why a house might have high radon. It just simply is something we have to address in order to minimize those long-term additional lung cancer risks. And one of the ways in which we can do that is to install, when we build a house, a passive radon control system. This is a primary goal of EPA to encourage adoption both voluntarily and regulatorily of new construction requirements at the local and state levels around the country. And so this is becoming more and more commonly seen throughout the country. And we just want to touch on some of the basic elements associated with them. Now, building a house radon resistant is not necessarily rocket science, but it does have its peculiarities. Now, our major, let me grab my spotlight, our major 4 elements with a house built with a passive radon system. Large grade fill beneath the foundation to encourage easy airflow of the air and the radon in the gravel fill beneath the foundation. A vapor barrier separating the concrete slab from the fill to create an additional layer of resistance to air movement and radon movement through the foundation and through control joints, floor to wall to footer joints, etc., into the indoor environment. A 3 to 4 inch PVC ventilation stack installed in an interior wall of the home in as straight a line as possible, connecting the fill to the outdoor air, creating a path of least resistance for the radon to move through the fill to the vent and up through and out to the outdoor air. Now, this does not guarantee that levels will be below 4, so we hedge our bets. And within 6 feet of that pipe up in the unconditioned attic. We put a junction box in case we have to then put in a low wattage fan to get us over the hump and below the EPA's recommended indoor action level of 4 picocuries. Now, ideally, we will stay below 4 in many houses with a passive system, just taking advantage of the stack effect of the house, which is why this pipe has to be in an interior wall of the home and also as straight as possible in order to maximize the chimney effect that we are attempting to develop naturally. A very common error, two very common errors with these installations of these ventilation stacks. One, they're put on an exterior wall or in an unconditioned space that will eliminate our stack effect and reduce our reduce or eliminate our passive pull. Or there is excessive horizontal runs, again, creating too much pipe resistance for the passive systems to adequately generate some flow of radon. We can address this type of system to pretty much any foundation type. We can connect directly to the gravel bed beneath the slab. We can sometimes connect into drainage systems such as sump systems. If we have drain tile, we can often tie directly into the drain tile for the ventilation stack. If we're dealing with a house on a crawl space, we can install a vapor barrier and then put the vacuum and the ventilation stack and some perforated pipe beneath that vapor barrier. So any foundation style of home can be addressed during build with a passive system. Now, again, our goal here is to take advantage of the natural stack effect of the house to generate our passive draws. This is obviously going to change somewhat throughout the seasons. We would expect the maximum amount of passive draw in winter when the stack effect is going to be maximized by that indoor to outdoor temperature differential, and that we would expect some drop off of efficiency in the more fair weather months. Keeping in mind then that we can also see some other impacts of our passive draw from combustion and ventilation equipment, as well as short-term impacts of weather events outdoors. If we're dealing with a higher efficiency home where we're trying to build in a certain degree of energy efficiency, not always put into our new construction homes, this can sometimes create some challenges for us in terms of installation of our passive systems. Now, assuming our high efficiency house does still have some unconditioned space available to us in an attic, we can still run our ventilation stack in the normal pattern, connecting the foundation to the outdoor air up through the home and through an interior wall, again, providing for a fan in the attic should that become reasonable due later on because of radon testing. However, if the house has a thermal envelope that is completely enclosing the entirety of the indoor environment, now our passive system up through the house is no longer going to be a viable activity. We have to have the potential for the fan in an unconditioned space. So we would have to, we'd have to basically pass on putting in a passive system and instead go immediately to an active system in order to meet our ventilation requirements in this situation. So this is one concern to pay attention to in our higher efficiency homes, where that thermal envelope is, which can impact whether we can get a passive system in or simply move to an active system when building the house. In any house with a passive system, anything we can do to control those points of entry from the foundation to the indoor environment is going to create additional efficiencies, sometimes very dramatically, of the passive systems, and definitely when we activate a system. So ensuring that our sealing work is done per the code requirements that Bruce is going to talk about here in a little bit, sealing the floor to wall to footer joints, making sure our sump pits have airtight gasketed lids to minimize loss of vacuum there, sealing of HVAC ductwork and other potential entry routes. All of these things can increase efficiency of passive systems. Additionally, if we're dealing with a particularly large foundation type, we may need a vent stack for each separate foundation zone. The most common application of this is in a duplex where we have a weight-bearing footer separating the wall, the interior wall between the two units. That would create two chambers beneath that foundation, and we would want a vent stack in both of those units of that that duplex following in order to maximize our passive controls. Reduce building depressurization through duct sealing in unconditioned spaces, air infiltration control, and fire stopping, as well as make sure that we provide that electrical supply in the attic in case after the house is occupied and tested for radon, it is still in excess of the action level of 4. Now, the advantage here is also an energy efficiency advantage. In a retrofit system, we are typically looking at a 70 to 90 watt suction fan that is running 24/7, 365 days of the year. When we're activating a properly installed passive system, we're generally able to use a smaller 20 to 25 watt fan, which generates an immediate 50 to 70 watt advantage in terms of energy penalty to the home. So this is our primary true outcome. If we still have to put in an active system, we're going to do so for much less energy and generally at a much higher efficiency of reduction. Now, if we're activating in a high efficiency house with a thermal envelope that is encompassing the entirety of the home again, this does sometimes complicate activating those passive systems, as we just talked about. Here we see a possibility of a roof fan installation. We might be able to install in the garage and reroute our piping to the garage, assuming there's no conditioned space above the garage that we would have to work around. But the fans, the suction fans, again, to reiterate, can never be inside the conditioned envelope of the home. So when we are designing our passive systems into our high efficiency houses, we do want to pay attention to the Indoor AirPlus requirements so that we put in a system that is still going to be functional and potentially activated if necessary. Can we also include radon systems during gut rehabs under the Indoor AirPlus revisions? And the answer is yes. Okay. However, we do not do passive during a gut rehab. The Indoor AirPlus does call for a full active system plus a radon test during the final inspection to make sure that we have achieved levels below 4. So our benefits then, lower cost. It is lower cost to build in a passive system in most cases than it is to retrofit a mitigation system to an existing house. This does help to generate some degree of marketing advantage and reduction of liability on the part of the builders by allowing the builders to say, we have taken the reasonable steps to help control this particular indoor air quality issue. We have aesthetic advantages when we can keep that pipe inside of the house and largely hidden from sight, which is a common complaint of retrofit systems. For some reason, people do not seem to like having pipes running up the outside of their houses. And more and more, we're seeing building codes that are requiring this either at the local jurisdiction or in many states across the statewide area, such as Minnesota and Illinois. In terms of the actual cost comparisons, and these are probably a little bit conservative. They might be a little bit better, might be a little bit worse, depending on where you're building. But generally speaking, nationally, we expect somewhere between $1,700 to $1,800 on average for a retrofit system, and most new homes can be built with a passive system for under $750. This assumes that we are not radically altering fill type beneath the foundation. So if we're already using a large grade fill, the cost of passive systems goes down dramatically. Now, in terms of how effective passive systems are, Bruce and I have done several rounds of evaluation of houses. We've done 2 rounds of evaluations here in Manhattan, Kansas, where we're physically located and where Kansas State is at. And we've also done 1 round of evaluations in Salina more recently, and that's what I want to briefly talk about and just give you an idea of some things that work and don't work in these houses based on what we have seen ourselves. Just for sake of argument, here in Kansas, these are the communities that have adopted the Appendix F, which is the optional appendix of the IRC that requires passive systems in single and 2 family houses when adopted, as well as the 2 counties as well. So we're slowly making some progress on code adoption here. Now, Salina, Kansas, and Saline County, a very high radon incidence county. You can see that we're running just right around 35–37% of all radon tests conducted in the county are coming back elevated. Many years ago, back in 2008, the county and the city of Salina received a care grant from EPA, and one of the activities that they adopted was radon awareness in the community. And this eventually led to the adoption of the Appendix F in 2013, and this was effective in June of 2015. So in 2016, after they'd had about 6 months of build time, we contacted 130 new built homes by mail, requesting volunteers for us to get in and take a look at those systems, give them a radon test, and see if we can find where the systems were working and where they weren't. In the event that the house failed its radon test, we did have funding through the grants to pay for a local mitigator who was also part of our evaluation team and is also our mitigation trainer here at K-State, Chad Robinson, to activate those systems. We had 16 initial responses out of our 130 letters. We actually got into 15 houses across the month of March. So we were doing our radon testing on these passive systems in winter. So here were the outcomes of those initial samples. I was using electret ion chambers paired, and we were averaging them. And of the 15 houses, you can see 6 of the 15 did still have radon values in excess of the action level of 4. Not uncommon. What we have seen here in Kansas with our evaluations, a properly installed passive system will reduce radon values by approximately 1/3 of what they would have been otherwise. Some other national evaluations have indicated that you might see as much as a 50% reduction with a passive system. Again, here in Kansas, we're looking at roughly a 30–35% reduction with a passive system. And again, with a low wattage fan, all 6 of those houses were reduced nearly to 1 or less. So we had extremely good reductions, particularly our highest value, which was still near 14 picocuries, brought down to about 1.3 picocuries. So things that we saw when we evaluated those passive systems, all 15 houses did have some elements of the passive systems installed. But there were a number of errors. Again, these were builders that had not done this before, so we were kind of backstopping their installation. So common failure. Oh, these are the things that we were looking at. Connection to the subslab zone, making sure that the ventilation pipe was actually in connection to the subslab. Sealing of the sump pits if present. Does the ventilation pipe actually penetrate from the slab through the roof? Appropriate labeling and accessibility in the attic for installation of a fan. So common findings, common system errors. 6 of the systems investigated had improperly or unsealed sump lids or sump pits near the ventilation pipe. 7 systems had no or incomplete labeling. 5 systems had incomplete clearance to add a fan in the attic. Several had the space for a low wattage fan, but would not have had space for a larger fan than that. 2 systems were found with truly excessive horizontal pipe runs. 2 systems had ventilation pipes that were completely enclosed in sheetrock, and we could not evaluate the subslab connection. 1 system had the ventilation pipe cut off in the attic, and because of a change to the Appendix F when it was adopted, none of these houses had electrical in the attic. This was removed as part of the code adoption process, which meant that for those 6 houses that we had to have fans in, we had to pay an electrician to come run the wiring. Real quickly here, and I'm going to turn it over to Bruce. The ventilation pipe is required to include space. This one barely had space for a low wattage fan. This was just electrical tape to seal this sump lid off. This was an inappropriate sealing of our sump systems. This was one of our inaccessible pipes. This was actually behind a 8-foot tall hybrid water heater, so we could not evaluate the subslab connection of this particular pipe run. Here is one of the excessive pipe runs. You can see where it starts in the floor, comes up and creates this emissional bend and runs all the way around the perimeter of this utility room before finally jogging up. Picture of the one that was stubbed off in the attic instead of penetrating through the roof. Now, this is what we ideally like to see. In this situation, we have a sump connection with a properly fitted lid with a floor drain trap in it, properly labeled, indicating that this is all part of a radon mitigation system. The piping does need to be labeled a minimum of once every 10 feet and once per floor that the pipe runs through. This is just showing you where we cut one of the pipes to verify connection to the subslab. So some key takeaways: a house with a passive system is not guaranteed to keep a house below 4. Once built, a house with a passive system still needs to be tested. If the radon value is elevated, the passive system should be activated with a low wattage fan. Installing of radon-resistant new construction enhances the potential for reduction of radon, but until we test, we do not know the efficacy of those systems. Were there any questions on any of that, Aaron, before I turn it over to Bruce?
Well, I think we've got a question on IAQ Plus and ERVs, but would you rather hold that for later?
Why don't we hold that till later?
And
I will do my best to answer that. I just recognize I am not an ERV specialist on this particular issue.
Yeah,
but Nick Hurst is on the call,
yes.
and he's a specialist in that for sure.
We'll save that one for Nick. And Nick, if you want to come in when we get there, we'll just raise your hand. One of the questions that's appropriate right now is, I think you said that Selena adopted a modified Appendix F. How was that modified, and perhaps why?
Well, the biggest modification was the elimination of the electrical code requirement. Why the builders that was the no-go for the builders for whatever reason. They apparently decided that it would be a cost issue,
perhaps.
Yeah. There were actually in the Salina adoption, there were 2 things that the committee recommended, and one at that point in time, this was a number of years ago, they were not requiring a membrane in typical construction of a slab. And so that was seen as a big obstacle from the concrete folks, concrete finishers and pourers there, contractors. And then by not putting a outlet in the attic, they could save $25. And so these were the things that, in the adoption process, was it better to get something or to have it be rejected? And so these were trade-offs that were made. Since then, the code department has required membranes to be installed underneath all slabs, but the electrical requirement is still does not require an outlet in the attic within the 6 feet of the pipe.
Okay, but now I think we have a question.
Yeah.
A vapor barrier is required under all slabs across.
Certainly that is, I can't speak in terms of all the jurisdictions across the country, but yes, in terms of a quality slab, there's no question that a membrane, a vapor barrier underneath, and in RRNC, it certainly is an essential component in terms of trying to create a tight cap to that subslab zone where you want the radon to move easily to the venting point.
Great. We'll keep those great questions coming, and we will answer those throughout. And Bruce, we'll turn it over to you.
Okay, I do see a chat question about a sealed crawl space. An attic in the conditioned space would require an active system outside the house. And I think if I understand the question, yes, if you can't put it in a crawl space because that's underneath living area. And if the attic is conditioned, if there is no attic, so to speak, because the thermal envelope is, as Brian indicated, for example, insulated panel system roofs that where the roof is the thermal boundary, then the fan does need to be outside the house. And I see the radon levels, there's a note, radon levels can change. Periodic testing in high radon zones is advisable. This is true. Radon, if you do a test under proper conditions, hopefully if nothing changes significantly in the home, the radon levels will be consistent. But if you test during a season of the year where conditions are perhaps not representative or as representative, for example, you test in the summer, it would be wise to test again in the winter in alternative seasons to see if because of temperature and weather and meteorological conditions, weather conditions, climate conditions, season conditions might lead to different radon concentrations. Okay, so let's talk about code adoption. And let's see here, Brian, I think.
Should still have control.
Okay.
There you go.
Okay. So you probably have all seen this at some point in time. This is the EPA 1993 radon potential map. And based on 5 factors, it identified high, medium, or low, red, orange, or yellow zones for each of the counties in the country. And you can see that the Zone 1 counties tended to be in the upper half of the country of the United States, and certainly in the upper Midwest, where we see the greatest overall radon potential. You may have heard that Iowa is #1 in its radon potential, with roughly 70% of the homes in Iowa expected to have radon concentrations in excess of 4 picocuries per liter. North Dakota's #2 with 60, Nebraska #3 with 55. Here in Kansas, it's about 25% according to the state surveys done back in the 80s, but it's really more like 35 to 40% based on the tons and tons of data that we have about Kansas now. And many states have additional data, tens of thousands, hundreds of thousands of tests that have helped them clarify the zone rankings of the counties. One of the purposes of the map initially was to say, all right, where is radon likely to be a greater problem than elsewhere in terms of number of homes that are affected? And where might we focus awareness and radon-resistant new construction efforts because of the greater potential benefits given the number of homes that might have result in low radon exposures if built properly. So where there is a statewide code or local codes is generally identified in this map. There's more to this than just yes, no, it's required or it's not. There are many different kind of variations associated with how codes have been adopted or are adopted and enforced, et cetera, across the country. So RRNC, must be in the building code for consistency. And this can be a problem depending on the jurisdictions that we're talking about and where the companies that work in those jurisdictions are located. Building codes are adopted by local and state legislative bodies, cities or states, and sometimes legislators will delegate this to an executive branch or advisory groups or committees. Other ones do it exactly by reference in law. And then many of them have jurisdictions that adopt codes developed by the International Code Council, which manages the family of codes with updates every 3 years, the International Residential Code, the International Building Code, and numerous others. Codes, of course, focus on generic safety and health to reduce the risk of imminent death. Environmental health is sometimes minimized in terms or not recognized as a high priority in terms of the codes and modifying the codes. And radon is about environmental health. It's one of the most significant environmental health risks that we face. The mechanism by which radon has been addressed in the building codes largely to this point in time is the presence of Appendix F in the International Residential Code. It's an appendix, it's not part of the body of the code, so it must be adopted by the jurisdiction specifically and can be adopted as an amended version, as you heard about with Salina, Kansas. So the code has been adopted in 7 of 8 states, mostly applies to 1 and 2 family homes or townhomes with a basic system. There's no fan, there's no test, there has been no testing required. You can see that NAHB has done surveys of the cost of installing according to Appendix F, and that has been about $350. And there's been numerous attempts over the last 2 decades to update Appendix F and make it more relevant and more effective. And I'm happy to share that this past year in the code process, in the process of updating, that Appendix F was modified and measurement requirements were added, and I'll talk about that here in just a bit. Just an overview of what goes into Appendix F. You can see the components and elements, much of which Brian addressed in the description of what RRNC consists of, and applied to crawl spaces, to basements, the requirements related to vent pipe drainage, allowing condensate that occurs in the vent pipe to drain back to the suction point or penetration, identifying the pipe, combination foundations, and then power sources, number 12. So that's what Appendix F consists of. When we look at the adoption of Appendix F or modifications, we can see that it's required by 11 states and more than 100 localities in other states. So this is always a key question when people say, what should I be doing RRNC? We say, make sure you check with your local jurisdiction to see if codes have been adopted addressing RRNC. In terms of geographic scope, sometimes the codes are limited to counties. For example, all counties in the 5 states you see listed there, or Zone 1 counties only, where the potential may be greater. And you can see about 5 or 6 counties listed there. Nebraska has a unique situation in that they have counties where their radon average is equal to or above 2.7, which is the World Health Organization's reference guideline. That was accomplished through legislation in terms of the building code. And then sometimes the adoptions address the type of occupancy and whether it is typically 1 and 2 family dwellings, plus apartment buildings, or all residential buildings. And then sometimes there are exceptions, like you see there in the last bullet, relative to architect or engineer designed systems, and or in Nebraska, the unique builder can convert it to an active system, but it has to be tested to verify performance. So which version of RRNC is certainly an issue. Different states adopted Appendix F as is: Maryland, Michigan, Washington. One state, Massachusetts, adopted Appendix F or the ANSI-AARST construction code applied to homes. Amended Appendix F in those 6 states you see listed there. And then New Jersey has its own original text. So it's obvious that statewide, depending on whether there is a home rule state or not, there can be statewide or local adoptions. There are non-mandatory statewide approaches such that if a local jurisdiction does it, they must use Appendix F if they're going to do something relative to RRNC, like Florida and Virginia. And then there is local adoption where any kind of amendment can be made based on the process of code adoption that occurs in that jurisdiction. And there are many different, we've been involved here in Kansas in 5 different cities in that process. It's all home rule here in Kansas versus statewide. But if it's statewide, it's a much larger, a broader participation that is necessary. So what I want to share with you that's most significant is the amendment made to Appendix F this year, which incorporates a requirement for testing. So it's Appendix F 104, where radon-resistant new construction is required. Testing shall be as specified here in items 1 through 11. And I've kind of summarized them. There are specific texts associated with each of 11 items, but here it's kind of the summary. And I just want to touch on that. Testing shall be performed, which is great, after the dwelling passes its air tightness test. In other words, it's essentially suitable for occupancy. All the sheetrock and insulation and things that create the air barrier and thermal boundary are in place. HVAC is also got to be complete. And if there are different HVAC system zones in the structure, in the home, they shall be tested separately, recognizing that different HVAC zones can have different radon concentrations, which we've learned from the states of Illinois and Minnesota, where they require foundation zone testing. In other words, if a house has 3 different foundation zones, basement, crawl space, slab on grade, a test must be conducted in or above those foundation zones. Closed house conditions apply, which of course is integral to any consistent testing process for radon in a home. It can be done by the builder, who is typically the owner, the design professional, rarely, or an approved third party. And that approval would come from the code official. In other words, they would say, we want, it's the state of Ohio. It must be one of the Ohio licensed radon measurement professionals complying with the law, for example, in a state like that. The tests should be not less than 2 days or 48 hours in duration. That's just a common standard requirement. Results less than 4 shall be provided to the code official. Results shall be provided to the code official. If it's 4 or more, a fan shall be installed. And where the 4 or more system modified, if it's 4 or more, the system must be modified until the performance result is less than 4. So this has been an excellent addition to Appendix F requiring testing. And That has been one of the major issues that we've seen in the review of and feedback about RRNC from mitigators across the country. People build RRNC because it's code required or because they've asked their builder or whatever the purpose is and reasoning is. And many times the home is never tested because, oh, it was built radon resistant, so we don't have to worry about the radon concentration. And unfortunately, we here at National Radon Program Services at K-State answer hotlines from across the country. And we not infrequently encounter people that say, yeah, I've been in this house for 10 years. I've had it built new. It's got a radon system in it. And it got tested as part of the real estate transaction. And the radon test came back at 8. So I'm confused. Well, it never got tested initially because, oh, it was built radon resistant. So the owner thought they didn't need to worry about it. It was going to be low. But you got to test to verify that radon is performing. And Brian talked about all the means, the ways in which systems are not likely to be successful. And so adding testing to Appendix F, which a jurisdiction can now use and adopt or modify if they already have Appendix F, I think is a great improvement. There are two AARST, ANSI, American Association of Radon Scientists and Technologists, American National Standards Institute, RRNC standards. One of them, rough-in of radon components, RRNC 2020, is a code version of the standard. And soil gas control systems of new construction and buildings, CC 1000, is a standard version. The reason there's two is to serve the code of the purpose of code adoption. RRNC 2020 was written and configured so that it was in code suitable language, which was one of the major problems with RRNC 2.0, which is the previous version of this standard. And so that's why this standard is available, to try and be more code friendly in terms of requiring rough-in. And so it's similar to Appendix F. It requires rough-in of an ASD system, and testing is not required for now. And there is a performance option associated with RRNC for testing out at less than 4 picocuries per liter. CCAH, construction code applicable to homes, provides minimum requirements for the rough-in and also minimum requirements for verifying if radon concentrations are below the national radon action level. And so this is got the same elements as RRNC 2020, but goes farther than that to be a more thorough standard in regards to testing and the requirement for testing. And this was adopted as an alternative code to Appendix F in Massachusetts. And we've had numerous unsuccessful proposals. I'm part of a working group that with ARST and EPA and CRCPD that is putting together, has put together code submissions, updates to the building codes for incorporation in the next round of International Code Council code amendments, focusing on several codes as part of the family of codes. So there's always more work to be done, but these serve as excellent documents and references. And then finally, there is CC 1000, which is the soil gas control systems for new construction of buildings in except for 1 and 2 families. So these are large buildings, multifamily, congregate, residential, educational, or commercial occupancies. And this lays out the consensus standard for minimum requirements in those types of structures. One of the great things that happened with ARST is that they provide now free access for public viewing to all their standards. So when people call, architects, engineers, others call us and seek what is the current requirements, what are is the industry standards for new construction and measurement and mitigation, we can refer them and they can access and view these standards. So you can see the website here. I think there's 13 or 14 standards total addressing all the different types of buildings for measurement, mitigation, new construction, quality assurance, quality control, device performance. So this is where you need to go when you're looking for what standards apply to the building types that you're working with and addressing. And I'm going to turn it back to Brian here, but I know that Nick Hurst is on the call, so he can wade in as well, because he sleeps with this stuff, I think it's safe to say. But I'll let Brian kind of talk a little bit more about Indoor AirPlus and the great program that it is.
So many of you are going to be familiar with Indoor AirPlus. It is currently undergoing its revision to version 2. And we were asked by Nick to just make sure to point out that we do have public open comment on the revisions through March 17th of 2021. If you are on that list and have set aside comments but not yet submitted them, or if you want to review these documents, we can help you get a hold of them to take a look at those changes. The goal here is to try to have the revisions early in 2021 and go to the second comment period sometime spring 21 to summer 21, so that we can try to have the review and final drafts out by summer to fall is the goal for this. There are radon components in the revision 2, as there were in the first revision, and these are going to be adopting and following the ANSI-AARST standards as our recommended practices. There aren't major differences from what we talked about earlier. Those are all going to be in play, but it is worth mentioning that the AARST ANSI standards is what is going to be recommended in this in the Indoor Air Quality Plus to get that certification. So the key takeaway: some exceptions apply to multifamily, and Bruce mentioned that we do have to go to the different standards, the new construction, the CC 1000, when we're dealing with things other than our single and two family houses. Application is still following the standard outline for the current revision, recommended in all zones that are zone 1, all zone 1 counties. In zone 2 counties, install a passive system or test upon completion, one of the two. In zone 1, include an active system or a passive system plus a test upon completion. In zone 3, comply with one of the options for zone 1 to 2 or provide the occupants with the citizen's guide to radon. Okay. So really what we're focusing on here, as we normally do, are those higher potential counties, the red and orange counties, to get our control systems installed. Questions?
Yeah, one of the questions we had was, is Appendix F relatively the same in both the 2018 and the 2021 code versions?
Well, the difference is the addition of the measurement, the testing requirement. That's the most significant changes. I don't know that there have been significant changes in other parts of Appendix F. That is the one that is most significant.
And to my knowledge, there has been no language change to Appendix F until the addition of the testing requirement. So it's been consistent language for many, many revisions now.
Great. And then let's go back to that first question. I did, in case we need some backup from Nick, I did promote him to panelist, but the question was from Richard, and he says, when building to Indoor AirPlus, if a whole house ERV is used and brings the radon levels below the threshold, is that valid, or would you need a separate radon system or a continuous run fan?
That's definitely a Nick question.
Yeah.
Okay. Nick, you are unmuted now, and Nick, do you want to take that? And
hey, Aaron, can you hear me okay?
yeah, absolutely. Hi, Nick.
Thanks for the impromptu question. I think the answer to that question is no, an ERV does not substitute for a conventional radon mitigation system, or at least a minimum passive system right now in radon zone 1 homes. With that said, I think there are potentially some radon mitigators who do retrofits in homes that might recommend ERVs in some situations to mitigate. Bruce and Brian might know better, but it's not the conventional way that we want to do it. We want to get that radon, the soil gas, out of the home before it gets into the home.
Right.
is kind of the intent here.
Yeah, you want to isolate it and mitigate it.
That's right.
Yeah, that's certainly the preferred mode, because with ERVs and HRVs, we have seen that maintenance, if they are a functional part of the radon control system, maintenance of those systems is just frequently not well done, not maintained, filters, etc., and you get blockages, intake blockages or filter blockages, and so pressure differentials are not maintained that would dilute or pressurize the space, dilute the radon or pressurize the space. So it's not that they can't be used, and there have been mitigators that have done that, but it does involve more maintenance than just a typical venting system for radon to prevent it from entering.
Great. And then Bruce, as we came online, we were, or getting ready for today, we were talking about your recommendation of, and I like that example where somebody thought they had a passive system, hadn't tested for 10 years, but it's National Radon Action Month. What should we all be doing? And then maybe the second part of that question for you, Bruce, is what types of home test sensor kits could we potentially use?
Sure. Yeah. National Radon Action Month. If you haven't tested your home for radon, you should test your home for radon. It's better to know than not to know. If you ever go to sell your house, it's likely a test will be requested by a buyer. Certainly the Surgeon General has recommended that across the country, every home. We do that. We recommend that. So test your own home, because then you know, and you can take appropriate steps. Hopefully it's low, but if it's not, then you can go ahead and get bids for mitigation and make the judgment call about whether or not to reduce that risk. And the reason we recommend that is because if you may live in your dream home, we hope you do, but if it's not your dream home a month from now and you're going to go to sell it, or a year from now, it's better to know and deal with radon, because you will likely deal with it in the real estate transaction. And so taking care of it sooner rather than later. If you're going to face the cost, you might as well benefit from risk reduction of having a system in place. So that's those comments. In terms of testing your own home, no question, you can purchase one of the single-use type test kits that are available online from numerous sources. You can see our National Radon Program Services website. This is our EPA supported and funded website. We provide for national technical assistance under our cooperative agreement with EPA. And we sell test kits at $15 a piece to the public for testing their own homes. You can get test kits online from numerous suppliers, from home supply and hardware stores. The key thing is to read and follow the directions with the test kit. And if you do so, you can rely on those results. There certainly are electronic consumer digital radon monitors that are probably 7 or 8 different models available now online. And we certainly encourage people who want to know more about their radon levels more frequently to do that, to purchase one. If they have a radon mitigation system, this is something that we see frequently. People who have had a system, they want to know more often. Rather than using a test kit, they want to be able to look online or on their phone by connecting to a consumer monitor. So we see this as positive. The more ways people are able to test for radon in their homes, the better. And yes, they're not perfect. These are devices that can go out of calibration over time. So it's important that they be properly used by consumers according to the instructions associated with the device. And so we field calls from users of these devices who are consumers. They're not appropriate for deciding whether or not to fix a house by a professional. They should use one of the one of the National Radon Proficiency Program or National Radon Safety Board listed approved devices for use by professionals. But these are devices that are out there that increase testing, and that's a good thing.
One thing I'll note on the consumer grade devices, particularly over the last year, as people have spent substantially more time in their houses, we've seen an uptick in calls to our hotlines from people these days, and they can, depending on the personality of the owner, lead to a bit of information overload and concern at the sometimes rapid variation of radon values in houses. One of the things that is lacking currently, unfortunately, with the consumer grade devices is any type of broad scale independent review of their outputs and what they're telling us. Bruce, correct me if I'm wrong, there's been one paper from the University of Ontario, or was it Toronto, that looked at a handful of them, but not all of the ones on the market. And fingers crossed, maybe we can address that in the next year or two.
Yeah. One of the things I wanted to just point out, you can see the website on the bottom of this particular slide. We were fortunate to be able to host and create a two webinar series last May and June with support from EPA and AARST as partners about radon resistant new construction code adoption. And so we have just an outstanding array of resources available to those who want to engage in their jurisdictions, local, county, city, state, in code adoption processes. Great resources there available to the public for consideration in code adoption processes. And we at NRPS at K-State would be happy to provide technical assistance to any jurisdiction, any individual or professional industry professionals or code officials in across the country in code adoption processes. We're currently working with the state of Michigan and their stakeholder group to do so, and happy to do that with any others.
Fantastic. And we'll post that link up to at the EEBA.org resources page. Quick question. Can, or maybe the better question is, should radon be tested on a site that doesn't currently have a structure built on it?
It's a waste of time and money to test the soil to find out if there's radon there, and there'll be radon there, and how much is there doesn't tell you anything about what the radon level will be in the building ultimately constructed on that site. It's far better to invest in making the building radon resistant from the get-go based on data and information about the location, the county, and the radon potentials there, looking at state data that may be available on the state radon program website. You know, it's obviously in some areas of the country, Louisiana, for example, where maybe 2% of the homes might have elevated levels of radon. The potential is much less there than it might be in places like Iowa.
Mm-hmm.
So that's part and parcel of what can plug into it, but it doesn't make any sense to test the soil to find something that's already there that tells you nothing about what the ultimate level will be in a home or structure built on that soil.
Perfect. Final question. How many homes in the US and maybe Canada, we include in that, have actually been tested or mitigated? Is there an idea of a rough percentage or a number?
At best, in Kansas, we are only getting about a third of all houses sold annually, including a radon test. That's worse in many states. It may be a little better in some states. After Illinois adopted their Radon Awareness Act, they went from about maybe 25 to 30% of annual sales, including radon tests, to nearly 70%. But even then, that's still 30% of houses not including a radon test at point of sale. So very hard to come up with a number on that.
Yeah. We do know that that radon awareness or disclosure legislation has been introduced. There's been a significant ramp up in testing and mitigation. And that is when we work with states and encourage state legislators to consider adoption, that is a significant way without requiring testing to increase testing and increase mitigation and ultimately risk reduction.
Yeah. Well, I want to thank you. I know we were talking as we got prepared for today, but Nancy, who you all know, got her house tested. And I don't know if it was part of National Radon Action Month, but I think she was at 8.8 and is now putting in there you are, Nancy. Do you want to talk about your experience with it, right?
Yeah. Well, we actually own two homes. One we're selling and had to do the test to sell it. That one was at 11. Which then prompted me to retest my house, which was tested a few years ago and it was fine. And now it's at 8.8. So we will have a mitigation system installed next week.
Fantastic. Well, it's such an important thing. I think obviously those of us that live in these zones where it's a 1 are more prominent, but everyone should get it tested. I want to thank our special guest, Nick Hurst from the EPA, who is such a fantastic partner of EEBA and KSU. And of course, many thanks to you, Brian, and to you, Bruce, for bringing your expertise and knowledge to all of us here today.
Our pleasure. And again, we are available to provide help and technical assistance nationally through our EPA support, which we appreciate greatly. And so we're here to help.
Fantastic. Thanks, everyone. Have a great
Thank you.
Thanks. Take care.
Bye.